Okay, we're going to give you a few tips on how to make the magnet motor. What you need to do first is get the magnets, and you're going to find these kind of magnets in a microwave oven. You get 2 magnets per microwave oven. They're going to be around the magnetron. You need to tear that magnetron apart, pull the magnets out. After you get 2 microwave ovens and get 4 magnets, you're going to use 2 magnets for the rotor itself. They're going to be the same size. You don't want to mix them up. The ones for the stationary, this is one magnet's cut in half, another magnet's cut in half. So you want to label these magnets, put a mark on them, like magnet 1, magnet 2, magnet 3, and 4. So all the pieces are going to be the same numbers. And then also you want to stack them together first. If you have the polarity wrong, you're not going to be able to put them together. I'm going to show you. You're going to try to put this in here. You got north on north or south on south. It's not going to go in. It won't go inside. So you need to get the polarity right and then mark them. Put size A on each one you pull off. So each one of these will be marked A. These are quite strong magnets. So all of the polarity are going to be the same. So you can mark all on side A, and then you're going to mark these off, 2 of them. You can put a mark on there, divide them in half, and then what I did, I took a cutoff wheel. A cutoff wheel, a high-speed cutoff wheel. You can put it in a drill motor or a if you have a bench hand router, you can put this in a hand router also, and just you're going to score this thing. Score it over here, score it over here, and then you should be able to take and hit it with a light piece of wood or stick, and it should just break in half. That's going to be the hardest thing, is getting those things cut in half without ruining them. And then what I did, I took a piece of, this is a piece of plexiglass, acrylic, and I glued it on here, and I put holes so I could attach these things and move them around, because I wasn't sure which way the polarity went. Since we're on that subject, all the I marked these with a compass, so I knew which was north and south. So I marked that on here. All of the poles are all in the same direction. These are all, can't really see it. There's an end mark here. See, these are all north. This is all north. All of these are north. They all have to go in the same direction. If you can have all south go this way, they all have to be south. And we did the plate here that holds that stabilizes the location of this. The rotor is a piece of steel. Then we have a mirror here that acts as a insulator, so it's the pin can rotate against this without being stuck to the magnet, but it's got enough magnetism in the end of this thing. Since we're on this subject, we have a steel screw that screws into about this location inside the wood, so it's picking up the magnetism through the screw itself, attaches to the metal plate behind the mirror here. What you do, you want to grind that tip on there very, very sharp, so it has very little surface area, so you have very little friction to slow this thing down. But it still has enough to actually, there's a little bit of a draw on there, not a lot, but just enough to keep it located on that front plate. Now, as far as the alignment of these magnets, that's critical. You can see these here. If I had a straight edge, let me see if I can find a. Here we go. That's just about aligned, but we actually have the magnet here in the front, just a little bit in front of this here. So what's happening is it's actually pushing it into this plate here, which helps stabilize it. Because once you pull it back, whoops, right here, it wants to go jump to the magnets on the ground there. But once it's actually out of the alignment, it wants to push it backwards. So it has to be at least on center and preferably a little bit in front of it. If it's too far in front, then you'd be putting a lot of pressure on here and possibly more friction. But it'll be a little more stable. If it's too far on center, or if it's any bit back from center line, it's going to push it off and fall and won't work. Same thing with the back one. The back one, If you have that too far forward, though, it's going to want to take and attach to the bottom. It's going to want to jump and attach. So it should be on center and a little bit to the front, but if it's too far forward, it wants to take and attach back here. So to stabilize it, you want to probably adjust the front one to be a little bit over center, if anything. The back one, on center is fine. And that should probably give you enough tips to get going here. We left these loose so we can actually adjust the rigging of the magnets and use tape to take and do the final location on them. But once you get the final location, you could probably put some glue in there and keep that stabilized. The other thing is the alignment on these magnets here. They need to be straight in line. And put a pen or something here when you're adjusting these so it's straight, because if that rigging is off a little bit, this thing's going to jump, oscillate and stuff, and when it slows down in a crash and grab onto here. So that's critical. These things are parallel to each other and perpendicular to the center line of the rotor here. So all of these were laid out with a square. This was laid out with a square. The center line on here, and as far as the gaps go, right here, I have this set from the edge of the magnet to edge of this magnet about 1 inch. So it's a 1/2 inch from center over to here, 1/2 inch from center over to here, and that's what I have on the front one also. And this location here is set by the magnetism. Although if you put this farther apart, it may go down farther. I'm not sure. I haven't tried that. This board here is about 7 inches wide, and it's about 12 inches long here. This is regular old, but almost 1/2 inch plywood. I think that give you enough tips to get going. We also have some videos of this thing in operation. Now, that's the other things. As far as getting it going, what we did here, we actually drilled a hole in the end and countersunk it a bit, and we actually have what would you call that? It's a grinding tip. So instead of spinning it by hand, you can actually spin it with the motor here. And it takes a bit of practice to get this thing, to hold this thing so it won't crash when you unhook it and stuff, but it's all fun. Anyhow, enjoy.